By operations inverse on video, this watching for thanks. Haha. We're talking inverse operations today, people. And if you caught it, what I did is I just started with the ending and I said the ending in reverse, which is what inverse operations are. It's doing the opposite. So inverse operations and PEMDAS, PEMDAS being parentheses, exponents, multiply, and add and subtract. So, and we do those in that order. That's what the PEMDAS is about. Here's some examples that we're going to do just to kind of refresh us. This is a refresher, merely a refresher. Example 1, 20x equals 5, 20 times x equals 5. The inverse of multiplication is division. So we're going to divide by what we're multiplying by. So we're going to divide by 20 on both sides. The 20 is divided out to be 1, so then we get x equals 5/20. This could also be reduced down to 1, I believe, a quarter. Hopefully I'm right there. 1/4. All right, let's look at example 2. Some number a divided by -7 equals 10. So this is division, so we do the opposite of that, which is multiplication. So we take this, and then we multiply it by the denominator. We're going to clear the denominator. You'll hear me say that a lot. Clear the denominator. So I'll rewrite it to show it. Then we're going to take the whole thing and multiply it by -7. Because the -7s will cancel out here, they'll divide it to 1. And then we'll be left with, and that 7 also, it gets distributed to this term and across the equal sign. A equals -7 times 10, which is -70. All right, example 3. The square root of x equals 11. Well, the opposite of a square root is the second power. So we take this and we square it. Because the square undoes the square root, so we have x is 121. Great. I'm going to take a second and get out of the way. Now I'm going to take a second and we're going to clear off this board and do a few extras. Okay, so here I have 3 more. The square root of x plus 5 equals 4, and the 5 and the x are under the square root. So let's see, we have to undo that square root. So we already talked about how do we undo a square root? Why we square it. We can't do anything with the 5 yet because it's taken care of in that square root. So we're going to square both sides. The square and the square root, and they're inverses of one another, so they undo one another. So we get x plus 5 equals 4 squared, 4 times 4, which is 16. And now we could do a few things. We can say what plus 5 equals 16. Or if we don't want to do that, we can think of inverse operations. And what's the opposite of addition? Subtraction. And that gives us x is, let's see, if I know my numbers right, it should be 11. And that makes sense because 11 plus 5 equals 16. There we go. All right, let's go here. The cube root of x plus 5 equals 4. So the cube root means some, which it's a little different. Instead of the square root, it's the cube root. It means we're taking a number, 3 of some number, and multiply them together to get something. So that's what it means. So we're how do we undo a cube root? By cubing. How do we undo a square root? By squaring. How do you undo a cube root? By cubing. So what that looks like is taking this and going 3 is the exponent. cube and the cube root. Poof. The cube undoes the cube root. If we want to be a little more succinct about it, x plus 5. 4 cubed, it's 4 times 4 times 4, so that's 64. Some number plus 5 is 64. Let's see, if I know my numbers right, that should be 59. Let's see. If I want to double check, I could subtract 5 from both sides, kind of going back. Subtract 5. And sure enough, 64 take away 5 is 59. Boom. All right. Next one, last one. Here we go. The quantity n plus 7 squared equals 17. All right. We can do this. How do we undo a square? Square root. There we go. So we have that. The square root and the square cancel each other out. Now I'm just going to leave the square root of 17 alone. I know it's bigger than 4 because the square root of 16 is 4. This is a little bigger, so it's a little bigger than 4. For right now, I'm just going to leave it to the square root of 17. That's the exact value anyway, square root of 17. What number plus 7 is that number? I don't really know, so let's play around with this. Just talking inverse operations, we're going to subtract 7 from both sides. So then the 7s cancel out. And then I'm going to keep this as just as is, minus 7 plus root 17. This is the exact form. If we put this into a calculator and get a decimal value, it's going to be approximate. But this is the exact value. That looks horrible. Come on, Southam. It's going on YouTube. There you go. It looks a little better. So this is the exact value. The approximate is if you were to get the decimal value. And this is also called a surd. Anything you have in a square root form is called a surd. A little Jeopardy fact for us. And something else I want to point out. X's and n's in these examples, they're not variables. I know oftentimes we want to say anything that we don't know is a variable. These are not variables. These are unknowns. Anyway, that's it. Inverse operations. Au revoir.